Okay, welcome back to my YouTube channel. In this tutorial, I'm going to show you how to estimate soil salinity based on Landsat-8 data in Google Earth Engine. In order to do this, I'm going to first estimate soil salinity based on a soil salinity index. Then from that index, I'm going to collect my training data and finally classify soil salinization in my targeted area using machine learning algorithm. If you like these types of video, please like the video and also subscribe to my channel. Okay, let's start. In order to do this, I'm gonna first define a study area. I used map dot center object and also map add layer in order to add my defined area to my layers, and also okay, first of all I have to collect my Landsat data. I have to look for my Landsat data. And copy the ID. The next step, I have to filter my study area. For this, I'm using filter bands. And filter the date. In the next line, I'm gonna filter images. Okay, I'm gonna filter image that has less cloud cover. In order to do this, less than. Less than 5% selected here. Okay, the problem is this. The reason why I'm using median in order to decrease the variety of my collected data and also divide them into individual images. And finally, I'm gonna clip my collected data into my study area just. So I have to save and run the code. We have the error for my space. date. Maybe there's no Landsat image for these days, but here, after fixing, you can see that I collected data for the study area. As I said before, I'm gonna first estimate soil salinity based on spectral index. In order to do this, I'm gonna define my bands. For estimating soil salinity index, I'm gonna use 3 bands: blue, green, and red. If I go to the metadata of Landsat-8, we can see this: blue, band 2, band 3, and band 4 for red. I'm gonna use my collected data, then band 2 for blue, I'm gonna rename it as a blue. And also I'm gonna do the same procedure for my other bands, green and red. In order to do this, I'm gonna copy the first line, green, band 3, again for band 4 also we follow the same procedure, band 4. Okay, now I'm gonna estimate my index, soil salinity index. In order to do this, I'm gonna define it first. Soil salinity index, say like this, the abbreviation. The collection that I have here. Here I have to define an expression which is related to the formula of soil salinity index. There are various types of soil salinity indexes, spectral indexes, and based on your need you can choose. I'm going to use expression. Okay, as I said, band 2. Multiply band 4 divided band 3. The output. Okay. Now it's okay. After defining our formula, we need to define band 2, 4, and 3. In order to do this, I'm gonna say band 2 is blue, 3 is green, which I defined before if you look at here. And finally, band 4 is red. Then I'm gonna rename the estimated soil salinity index to soil salinity index for 2020. I add estimated index to my screen. I go to this is the estimated soil salinity based on spectral limits. As I said before, I'm gonna use this index in order to collect some training data for my machine learning algorithm. In order to do this, I'm gonna give them some color. Blue for very low, low, moderate, high, and very high. Okay. Here we have a soil salinity estimated based on a spectral index. In order to prepare some training data for machine learning methods, I'm gonna use geometry, new layer, edit the layer. I'm gonna give it a name, very low, class very low, feature collection, and also in properties, I'm gonna say soil salinity. The value of the class would be 0 and a color. Okay. Now my course is ready for collecting some data. In order to do this, I'm gonna go further. Sorry. We can use different sets of tools here for collecting data, polygon and point. I'm gonna use polygon here, point. This belongs to class very low soil salinization. Try to collect more training data. Also try to collect them precisely. And also pay attention to be distributed equally over your study area. Okay, as you can see, I collected 31 training data for class very low. The next step, I'm gonna go to the second class by adding new wire. This time I'm gonna use class low, again another color. Property would be soil salinity, and value for this one is 1. Now okay, again I collected 31 data for class low, and I'm gonna add class moderate. The same procedure for this one also, value 2. Green color is the representative of soil salinity in moderate level. .31 point also for this class. Again, class 4 would be high soil salinity. Try to collect the pure pixel, which improved your classification. Okay, we collected 31 points and also for class height, and the final layer would be very high soil salinity. Value 4. Okay, we collected several training TCPs for our training sections. Then I'm gonna save the collected data. As you can see, all of them added here. The next step, I'm gonna go further and prepare my data sets, training data. In order to do this, I'm gonna use training data, and I have to merge all of these collected data sets. First of all, I'm gonna use flow in order to make it as a unique data. Okay, as you can see, I merged all my classes: very low, low, moderate, high, and very high soil salinity. The next step, I have to define the bands that I'm gonna use for my classification. If you go to the Landsat-8 data metadata, you can see different bands here. And so information regarding the bands. And here I'm gonna choose band 2, 3, 4, 5, 6, and 7 for my classification. Okay. The next step, I have to align these datasets together. This is related to sample region from training data. I'm gonna back again to my collected data, and I'm saying from collected data, select bands that I defined at the previous line. And also sample region. Then I have to add further details about this. collection would be my training data. Properties I defined it before. To remember, for example, this one I added SS, soil salinity, and escape. The special resolution of Landsat-8 data is 30 meters, and I'm adding that one. Okay. Okay, in the next step, I'm gonna define different parts of my classification algorithm that I'm going to use. As I said before, I'm going to use machine learning in order to classify soil salinity distribution for Landsat-8 data. A classifier would be super vector machines as part of machine learning algorithms. In order to call it, I'm going to use classifier, and you can see here various types of supervised and also unsupervised techniques for classification. I'm going to select super vector machines and train. The next step I have to define, as I said, several parts of my classifier. For the first time, features that should be used during my training would be my training data. Combination of training data and also bands. For class property, I'm going to use SS as I entered when I collected training data. Also input properties would be in my band. Okay. Until now it's okay. Then we are going to the next step and classify the model. I'm going to use classify as the name, and again my collected data, Landsat-8. Then from these data I'm saying select bands. The next step I have to say classify based on bands and also training data. Here I'm defining the classifiers per vector machines that I defined before. Finally click the classified maps into my study area. We also defined the classified sections. Now I have to add classify it now as a layer and give it several colors in order to be very good visualize. The first step, I'm gonna define the mean and max. Mean is 0 because we have 5 classes that it started from 0 to 4. Now I have to give them different colors based on their value. For this purpose, I'm going to use palette and define some colors for each class. For example, for class very low, blue would be a good color. For class low, green. For class soil salinity moderate level, yellow. For soil salinity with high level, red, and very high would be brown, a good option. Fix it. Finally, I have to give it a hide image or map would be an appropriate option. Okay, as you can see, we define the training data, classify, and also classify our maps. Did it before. Now I have seen and run the code. Now we need to see our classification result. I'm going to move this and we can see the classification result here. Brown shows the area with soil salinity distribution, very high soil salinity distribution. This is the index, the result of index, spectral index, and so this is the result of machine learning algorithm. In order to visualize them in the spatial analysis software, I'm going to export my result to QGIS. In order to do this, I'm going to use tool export image into Drive. Define various parts of this command. Image would be my class 5 map. Description. I use soil salinity. Region as the study area that I defined before. Scale. The spatial resolution of Landsat series data is 30 meters. Now for this, I'm going to use 30 max pixels. If I run the code, I can export my result to Google Drive. From task, we can see it. There is a space between the words, it's not gonna work. It's gonna give you an error. You have to fix it, and it's gonna take a while in order to export to Google Drive. As I said before, these types of method will be helpful for people who don't have training data and don't have specific knowledge about the soil salinity distribution. By using the spectral index, they can find also some collected training data and use training data for classification based on learning-based algorithms such as machine learning. That would be very useful. And also you can have a comparison between spectral index classification and machine learning algorithms. Okay, it's finished. Now I can go to my Google Drive and download my result in order to visualize them in QGIS. You can use other software as well, like ArcGIS if you want. For opening data on QGIS, I'm going to use Open Data Source. Format of the data is raster. Okay, as you can see, our datasets, 5 classes added. The areas with high brightness show very high soil salinity, and so on until 0. But it's gonna show you very low soil salinity.